Well, hi and welcome to my shop, and thanks so much for joining me here. It's January 27th. Again, another cold day here. Hey, up on my bench here. Where is the stuff? Here it is. So I'm done with the record player, at least for now, and it's time to start looking at the radio. And what you're looking at here right now is a power supply, which is in a separate chassis, which is kind of unusual. Down at the bottom of the cabinet, the speaker in behind it, antenna to the left, some excessive amount of wires running around in there. So what I want to do is I want to take out that power supply. Here's where the radio is. The radio is just up above here. So radio supply looks like a pretty simple thing to get out of there. So I'm going to do that. Okay, now this plug will come off quite easily, no problem. I think there's just a couple of screws here. So in most radios, of course, the power supply is right part of the main radio chassis, but in this case, for some reason that I don't understand, they've got a separate chassis with its power supply transformer and the rectifier tube sitting down here. Now maybe that was kind of a attempt at doing something kind of modular. Perhaps this power supply worked in a number of different radios. So they were able to manufacture it, separately like this, and then utilize it in different arrangements. I don't know. It's a little unusual to me. I see something else that's a little unusual here about this. Maybe not unusual, but just curious. So there's an unpainted area here, or stained, and a stained area here. This is quite a bit larger than this. Why would they bother doing that? Let's see if that's getting caught on camera. Yeah, you can kind of see it. There we go. You can see I've cut the cord off already. Okay, let's bring this up on the bench. And before we do anything else, we'll take a look at this and just see what we've got going here. Well, not a lot in there. Not a lot at all. Just wires. Transformer, the socket, there's nothing in there. So this is the feed. What is this? This is the feed to the motor, or to the record player motor, basically. Since this is the only cord that's being plugged in the wall, so to speak. Clearly, we'll have to change this out when it comes time. Can't do much with this all on its own. I wouldn't even try to power it up. I think we need the rest of the radio. Okay. Guess I'll start looking at how to get that out. Well, there's a lot of stuff taped together right here. Big bundle of wires. Let's see if we can untape it this way. So a lot of this has to do with someone's attempt to attach an additional speaker to the unit. There was a switch involved, which might have been to turn the external speaker on and off. I've cut that wire away already. There we go. There we are. Now we can see for sure what's going on. So this is going up to the radio to supply power. Clamp there, gotta loosen it. And look up here, And the speaker. Now, I can't see from where I am. I can't. Well, here, let's use the camera. Take a look back there. What's going on back there? That looks like voice coil terminals on the back of the speaker there. I just can't quite see from the light. Maybe I can do this. Maybe I can move this. A little too much light on the deal. I can't quite make it out because I'm in a very awkward position here to see it. We'll leave all that as is. The speaker itself is plugged in here. Pull that plug out. Okay, that's good. Unfortunately, a piece of wood's kind of blocking the view there. Let's see if I can do this. How's that? So. Okay. This might not be ideal for the video, but I need lots of light so I can see what I'm doing. So what I see are 4 screws. The screws have to come right out. Pretty sure at that point that chassis will just fall right off. But I do have to deal with this situation here. Okay, this is the antenna terminals. And it looks like they just pull off. I think it's a big deal. I've already photographed this with my telephone, so I know which wire goes where. But in order to fix the radio properly, I will need this antenna connected. This antenna forms an important part of the radio, a tuned part of the radio. We can't ignore that. Okay, need a green handle here. Green handle Roberts. What's this loop here? Why that? Okay. The antenna itself is just held in by, again, more screws in the corner. It's come loose here, but that's no big deal. Okay, so I'm going to remove the chassis, radio chassis, and get it up on the bench here. Surprisingly enough, these are machine screws. They aren't wood screws. Likewise down here. These are machine screws. Okay, now I've taken the knobs off. So I think this radio is going to drop out when I take these last 2 screws out. Oops. worth it to live in Canada just to have this type of screw, these Robert screws. There we go, is it coming out? Yes it is. There it comes. Oops, whoop, I did overlook something. I didn't release this. Check out. There we go. As is often the case, it's been inside of a cabinet and it's as clean as a whistle. Wow. Wow, that's really, really clean. Now I see some yellow here, yellow corrosion product on these pieces. I could easily be mistaken, but I think there's a chance that's a bit of a health hazard, I believe. Okay, I'm not sure. Same thing on this one. Some yellow here. I think it's an anti-corrosion covering or material they put on. I'm not sure. I'm going to make sure I've been washing my hands a lot while I'm working on this. So on the top, looks great. Looks fantastic, in fact. You think it just came out of the factory. Wow. Let's turn it up on its side. What do we got underneath? Well, this radio, I think, has been worked on. These capacitors here are all replacements. Maybe from around maybe the 1980s or something like that. Down here, over here. Only this one didn't get changed. Oddly enough. Looks like a very nice job. So my understanding is that the original owner of this, who is the grandfather of the current owner, if I got the story right, was an electrical person. And I think it's pretty clear from looking at this that this is their handiwork and a very nice job done. No doubt about it. This means not a lot for me to do, that's for sure. All I got to do is change out this one. I don't know if I should be disappointed or not about that. Lovely job done. There's no reason to think these capacitors are bad. Those are much higher quality than the original ones. They're not paper wax. And no reason to think any mistakes were done. Whoever did it did a nice job on it. Yeah. Very good. So in effect, other than this one capacitor, the owner of this radio will be playing a radio with his grandfather's handiwork in it. That's really wonderful. So no big deal to change this one capacitor. The big deal here is to put a new power cord. It's not really a big deal on the power supply back here. Somehow connect it back to the speaker. It must be connected to the speaker to be operated. So I'm probably going to have to take the speaker out and stick it on my bench here, as much as I'd rather not. Well, then all we're doing after that is just a little bit of tune-up. Something perhaps his grandfather couldn't have done because you need an array of equipment. And now his grandfather may have had all this kind of stuff. Maybe his grandfather was a radio repairman. I don't really know what his electrical background was. Well, that's very surprising. I think the number of times I pulled a old radio out of a chassis that someone has given, out of a cabinet that someone has given me to work on, and discover that, hey, someone's already done the work. I don't know if that's ever happened before. Fantastic. Okay, so we're going to focus on this one capacitor and then getting everything connected up. This might be a one-day deal here. And spend more time taking it out and putting it back in the cabinet than actually working on it. Great. Yeah, and I think I'm going to make a comment about the record player before I forget, because I'd like to say this. So it looked like the record player was a replacement from the original record player. It has a stereo cartridge in it, in a mono player. That record player wasn't available at the time this console was originally built. The interesting thing is, when I dropped the record player back into the console behind me, I noticed that the there's springs underneath to suspend the record player, and isolated a bit from the cabinet and motions in the house when you walk across the floor and stuff like that. They line up perfectly with the cabinet arrangement, as if that record player was really made for that particular cabinet. Well, to me, that's a little surprising, unless the record player was built as a replacement for an earlier version of the record player that was in there. And so it was built with the opening in mind, the position for the suspension springs to go. It's actually a replacement record player, an upgrade record player. And I guess it would be marketed on the idea that it's a drop-in replacement. It's going to fit perfectly. It's not something you've got to get out your saw and start chopping at the wood to make it fit. So don't know if that's true, but would seem to be true. I just wanted to get that on video. It's just another interesting element of this whole thing. Well, you got to ask yourself, why did this fellow leave this one capacitor here when he changed all the rest? And it was not easy. Some of these, you see, there's an orange one tucked way in underneath here, brown way in under here. No, these are not easy to do. So put a lot of effort into it. There's no doubt about it. Why did he leave this one here? I'd have to guess, because I don't know. Because he didn't have one this size, which is far-fetched. It's really far-fetched. It's got a whole range of sizes in here. I don't know. It's curious. Perhaps he was smart enough to realize this capacitor is not very important. Or this is a replacement that he put in. Tiger 0.1. We'll give this thing a test. 400 volt capacitor. It's quite curious because it's right up on top here. I mean, you couldn't miss it. I might be able to put this one, oops, right into the, yeah, go right in like that. So I will replace it. Maybe in his mind he said to himself, someday somebody will replace that. Turns out it's me. Get rid of this excess piece of wire. It's going to work. Okay. Years ago, or a few years ago, I would normally video all the capacitor replacement work. I've taken more recently to not do that, except there's something unusual about it, just to cut the length of the videos down, and because it's not very exciting to watch, I'll let this one go in. In this case, I think we'll just go on the wire stub here that I left. I see it's got some wax on it. Try to scratch it up a little bit. Get the electron showing. I mean that honestly. When you look at a piece of dull metal, you're looking at some kind of corroded surface. Could be very thin corroded surface, like tin might look. Tin has kind of a flat look to it. Aluminum could be like that too. It looks a little flat. And if you scratch it up, you see this great shine in the scratch. The shine is the electrons. The effect of the electrons. Of course, you can't see an electron. Electrons are very, very tiny, whatever they are. I think it's interesting that human beings have figured out so much about the physics of the world, the universe. So much is sort of known, yet the really, really fundamental questions are not known. So what is an electron? We know about electrons. We know what they do, what they don't do, what you can do with them. But all this stuff that humans have come up with, messing around with electrons, really don't know for sure what exactly they are, if you could even ask that question. Because as human beings, we're kind of limited to our part of the universe. And I don't mean, our solar system area or where we are in the galaxy. I don't mean that at all. I mean what it is we're able to perceive, both in terms of sensory perception and in terms of our ability to get a grip on it. Because the world, the universe appears a certain way to us. Now, for instance, if you're into this stuff, you know that gravity is really an effect of the bending of space and time. But we just can't. I can't conceive of it. I can't conceive that. The reason this is sitting on my table is because space is bent, but I can't make the perception work in me. I can't model it. Let's test this and see what condition it's in. Okay, so I have a special testing device here. So what this does, it actually does two things. One is it does two tests. One, it'll tell you the capacitance of a capacitor. You can measure. It uses a bridge technique for doing that. The other thing I use it for all the time is you can apply a DC voltage to a capacitor like this, and then with a very slight leak through the capacitor. Capacitors are not supposed to leak DC. The effect of it will show up in this magic eye here. You see the eye is open right now. The pie is dark at the bottom here. There's a pie-shaped opening. So I'm going to turn this spring-loaded knob here. It's going to apply a voltage to the capacitor. It's going to apply, it says 25 here, but it's actually 50 volts if you measure it. For a moment there will be a rush of current into the capacitor to charge it. And during that time the eye will detect this, or will reflect this current. But then once the capacitor is charged, in just a matter of a second or two, the eye should open up again. If the capacitor has no leak, it'll look like that again. But if the capacitor is leaking, look at that, it's perfectly good. That was a perfectly good capacitor. I should put that back in my tray. So that's very surprising. It's very surprising to find wax capacitors coming out of old radios that test this way. Let's go up on a higher voltage here. So we'll go up to 250 volts. It's a 400 volt capacitor. Takes a little longer to charge. You see the eye is not opening anymore. Let's give you some way to kind of grade the capacitor a bit. Let me give it a moment to discharge. We'll try it on 150 volts. Still open a bit. So not perfect, but certainly much better than most capacitors that I take out. I don't think I have any old ones laying around here to demonstrate with, but if I did, what you'd see is I put it on 50, turn that knob, and this thing would close and never open. That's more typical. So once again, Grandpa knew what he was doing. How he knew, how could he have known that this was in good shape? Again, it could be it was brand new to him at that time. We don't know what time this work was done. These orange drop capacitors have been around for quite a long time. It's a fairly large capacitor. Maybe he had a box of these larger ones. Let me just check and see. All is good. Okay, that's all there is for me. This is like the easiest radio I've ever done. Done. Now, The next challenge is to get this operating on my bench. Be interesting to see how well tuned it is. If Grandpa had the equipment, there's no doubt he would have tuned it, and my guess is it would still be tuned fine. What am I talking about with tuning it? So if you look down in these cans here, you see screws in the top of the cans, this one and this one. Each of those screws is a small capacitor. Then inside the can are a couple coils, a transformer in fact. So what you're doing is you're tuning by adjusting the capacitors, the primary and the secondary side of these transformers, and you're tuning it to what? You're tuning it to a particular frequency called the intermediate frequency. Radio like this, it's almost certainly 455 kilohertz. That's just below the AM radio band. AM radio band starts at 530. This is just below it. The magic of these radios, the magic of the super heterodyne radio, is the bulk of the radio circuits, amplifier and all that stuff, is all fixed tuned at that frequency, 455 kilohertz. The only part that's variable tuned, there's two things that are variable tuned. And the giveaway is that the tuning capacitor here has two sections. The two things being tuned. Well, one of them is the antenna, basically. The antenna forms a loop. We saw it in the cabinet. The capacitor is hooked up probably right in parallel with it, one of these two sides, probably this bigger side. And you're trying to make that antenna resonate at the frequency you're interested in. So if you're going to tune in 590, the sports channel, you're going to adjust this capacitor by turning the knob in the front until this capacitor and the coil are resonating at the desired frequency, 590 kilohertz. The interesting thing that happens next is what's going on with this other piece here. So this is working in conjunction with the coil. It's probably underneath the radio. Okay. This coil here. And it's being made to resonate at a frequency above the target frequency by the amount of the IF frequency. So to make this a little clearer, let's say you're going to make some nice round numbers. Let's say you're trying to tune in 500. Actually, 500 is not within the range. A million. Let's say a million. You're going to tune in 1,000 kilohertz, a million hertz. So you have this adjusted. That would be somewhere in the middle here, like this. Okay, so now the antenna and this are resonating at around a million. If there's a signal there, the signal will be, I don't want to say helped out, but will be, yeah, kind of helped out. The signals not at a million will be suppressed. And so once you get past the antenna and start heading into the radio, you're presenting the radio with pretty much the channel you're after at a million hertz. This guy is tuning against that coil at a million hertz plus 455 kilohertz. So that would be 1.455 million hertz. There's an oscillator in here. That's what this is doing. I didn't really explain that well. So this is the tuning part of the oscillator. So now you have the incoming frequency at about a million, and you have this guy generating another signal, an additional signal, at 1.455 megahertz if everything's tuned right. Those two signals are sent together into a tube. Almost certainly this guy here, 6SC7, I'm just guessing. That's going to be the one. Could be wrong. Could be this one, 6SA7. Could be this one, I'm not sure. One of these tubes is the first tube. These two signals are come in to the tube together. The tube is specially designed for this normally. It has two grids, two inputs if you like. One for the antenna signal at a million and one for the oscillator now at 1.455 million. Inside the two waves interfere with each other, the two frequencies, and you end up with not only the two original frequencies, but you end up with 2 more frequencies. I should really show them kind of on either side. Not really. Kind of. What you end up with is the sum of the 2 frequencies and the difference of them coming out of that tube. So you get 4 things coming out of that tube now. So one of them is the original frequency you're trying to tune, 1,000,000 hertz. Another one is a local oscillator frequency coming out, 1.455. Another one is the addition of those 2, so that would be 2.455. And the last one is the difference between the 2, which is 455 kilohertz, which is the frequency that these guys are tuned to. So all 4 of these are presented to the next stage. It's called the intermediate frequency stage. But that stage, these stages, are tuned only for one of those 4 frequencies, 455 kilohertz. So that's the one that carries on. Just one carries on. Right. Gets amplified almost certainly by this tube, tuned again, 455 kilohertz, and then it's on its way to the final stages of the radio where the audio signal is recovered, or detected is the word they like to use. It's an old word. Detected. Then it's converted or altered in such a way that only the audio signal remains. Then that's sent through the final amplifier tube, probably this one, I'm guessing which one it is. This one probably. And then to the output tube, this bigger guy, whose job is to drive the speaker. So those are the stages of a radio like this. Super heterodyne radio. Super meaning above your hearing. Heterodyne is the mixing of the signals together to get everything. And that's fed on to the IF, but only one of them can get through. The 455 kilohertz. Subsequently, that is, because this is a fixed tuned area, it's much easier to build a radio like this. So you get high levels of amplification and other goodnesses out of this kind of arrangement. If you didn't do this, if you didn't do the frequency conversion thing, which is what this radio is doing, it's a frequency converter, then you'd end up with just a whole bunch of these guys in a row. If you go back to the 1920s, that's what most radios were. They were called TRF, tuned RF radios. Every stage is just another one of these. It's very tricky to tune. You go from the low end of the band to the high end of the band, you got trebles, tricky stuff. So the inventor of the super heterodyne prior to this was the heterodyne, the neutrodyne, the ingadyne, the umbadyne, all kinds of dynes. As experimenters, smart people were figuring these things out. But once somebody came up with this scheme, the super heterodyne, it was thumbs up all the way. So around about 1929, 1930, 1931, all radios were converted, or all radios being manufactured were this type. Super heterodyne, right up until today. But of course today another revolution is happening in radios. A very exciting revolution is happening in radios. This system is going away. I don't mean the vacuum tubes. I mean your modern, your 1990s stereo, using exactly the same system, super heterodyne type system. That's going away and being replaced by what's called the software-defined radio, in which the raw antenna signal, and maybe it's not quite raw, it may be somewhat manipulated, is fed into the computer, and the computer, because they're so fast these days, of course, super fast computers, can use digital techniques to recover the signal, the audio part of the signal. They no longer require this super heterodyne technique. So when you're tuning away on the front, although you are tuning the antenna to match along, track along with your tuning, what you're really doing is you're changing that oscillator frequency from where I had it here at 1,000,000. So I'm tuning in the station at 1,000,000. I got the oscillator running at 1.455 million, that's what you're really changing here. And as you're changing it, it's mixing with the signals coming from the front end of the radio. And if there's anything at 455 kilohertz, comes through the radio, out the speaker. That's how all these guys work, right up until now. And I have to tell you, I have such mixed feelings about all this because I know a lot of stuff about these radios and working away on them and that, yet I realize that the radio technology revolution is going full steam. If you look at what's going on in ham radio, some ham radios have been developed using this software-defined technique, SDR technique, and it is just wonderful because once you've got those signals in your computer, the computer will do all kinds of things with it, make all kinds of displays, all kinds of things become possible. It's wonderful. So I'm pretty excited about that stuff. Okay, enough about how these work. I want to find out if this one works. What are the chances that it doesn't work? Really low. I think really low. So I'm going to have to spend a little bit of time. I got to get the speaker out of that cabinet, unfortunately, and get it up here because I'm going to need to plug it into the speaker plug back here. We have to use the speaker that comes with this radio. I can't use another speaker. Not without an awful lot of care and consideration. So I think I'm just going to work away on that on my own. Next time you see me, I'll have a speaker up here, and we'll take it from there. See if this works. Okay, it wasn't too tough to get this out. Speaker's in beautiful shape, as they often are. They almost always are. This has been protected in the cabinet. The greatest risk to this speaker, it's out here on my bench, there's lots of risks to it, but another risk is returning it to the cabinet because the screws that this rides on stick out quite a ways. So as you're putting this back in the cabinet and you're trying to watch 4 holes all at once, if you miss one, there's a chance that that will pierce the cone here. While I have it out here, how come when a speaker's out like this, it doesn't reproduce bass very well? If you have any experience with this, you know that. There's a reason why speakers are in cabinets. So what's happening, and this is what will happen here too while it's on my bench, is the speaker cone is going up and down, it's pushing the air up and down. Underneath, of course, it's pushing at the top, it's pulling at the bottom. So what will happen is the air, which you hope is being vibrated all the way to your ears, may not be. Instead, the pressure may be relieved by air actually slipping around the edge of the speaker, getting around behind it. So as the cone goes up and down, you've got air shooting back and forth like this. It's like a short circuit in the speaker. Most effective at the lower frequencies, as you could imagine. The higher frequencies, not as much air can make it around in time. So you end up with the bass kind of disappearing. So you need some way to baffle that air. So one way would be to put a board on here, great big board. You go out 10 feet in all directions. And then the air on the top here cannot make it around to the bottom. It'll just end up pushing more air out the top. You can imagine the speaker feels that a little bit, that it feels it's pushing more air now. Not that that matters, but I don't think we can afford to have 10-foot circular boards around our speakers in our house. That's a little inconvenient. So somehow you've got to block the air from the front from getting to the back. So instead of a board going out forever, why not just have it go out a little ways and then maybe box in the back of the speaker so that the air in the back cannot get around to the front and vice versa. Now that's what a speaker cabinet's doing. It's simply preventing the front air from getting in contact with the back air. That's why a little hole in the speaker is very important, because a speaker pushes against the air, pressure goes up, any opportunity, and the pressure is going down behind it, any opportunity for the air in the front to get around to the back, it's going to take it. It'll go through the hole. The holes in speakers are often tears and other things are happening. They're kind of flappy holes. So as the air zooms through, you know, because Mr. Bass Player is hitting a low note, the paper here will flap a bit, make a buzzy sound. Bzz. Same thing with why there's a seal here. This is a cardboard seal. It's meant to press up against the back of the cabinet, and where it's screwed up tight, so no air can slip through here, sneak around and get in there. So that's just a little bit about speakers and cabinets. Of course, you know, the cabinet is less than ideal. The cabinet has other problems. There's resonances in the cabinet. There's all kinds of things that have gone on, and people have figured out about how to deal with this problem. But the root problem is separating the front air from the back air, not letting them be in contact somehow. There we go. Now, while we got this out here, why do we absolutely need this speaker? Why not just throw another 8 ohm speaker on here or whatever? Because of this guy right here. So this transformer, I think a lot of people would not realize this. There's a primary side of this transformer with high voltage on it. A tube plate voltage, so it could be a couple hundred volts in a radio of this sort. Could easily be a couple hundred volts coming up into here. And so then the signal is in this pressurized voltage at a couple hundred volts. There's a signal in there, the audio you want to hear. The transformer will only pass through the variation in the current, so all that shows up on the secondary side of the transformer are the variations or the audio. The 200 volts doesn't come along. So you manage to separate away the audio from the voltage that's required to make the tube operate, the pressure that's required. Of course, this is designed in conjunction with the speaker, in conjunction with the radio. There's issues around impedance and all this kind of stuff. It's all worked out by the engineers who designed this stuff. And now someone's come along and hooked up all these extra wires to it. Quite a plethora of wires. Look at this. I've got a lamp cord connected to 300 ohm. So the first thing I'm going to do is I'm going to reduce the wires that are hanging around here, because the last thing we want is a tug on any of these wires by accident, and stuff like that can happen. So I'm just going to cut them off. They're useless anyway. To some degree, this should not have been done. Okay, so there's a little tricky thing done here. This explains the switch. Here's what I do with the switch. The switch is laying around here somewhere. There's a toggle switch. This switch was hanging out the back of the set. What it was for, I don't know. It's just an on-off switch. Pretty old one. But now I see what Grandpa's done here. So the wire that is wound in the transformer is usually the same wire that pokes out. It usually goes straight to terminals of some sort, so they don't get moved around and tugged on when you're adding additional wires, when you're building this thing. And I don't mean these kinds of additional wires. What Grandpa's done here is he's cut one of those wires that's coming out that used to go to this terminal. Where this light, I want to get rid of this. Let's get rid of this thing here. You know, I'm not gonna cut it off. I'm gonna try to solder it away and get it off. He's interrupted it. I think what he's done is he's made an arrangement here where you can shut off this speaker in favor of a remote speaker. So I think that's what he's done. He's got this deal here, which is pretty curious. This cord which goes to here. Don't know exactly what he was up to. I'm going to cut this one away. And be very careful to not cut the wire that comes out of the transformer, because doing that will ruin it. I don't want to ruin it. And it's so easy when you're doing this kind of stuff to grab the wire you're after and its brother by accident, and you only know after the fact that you cut the brother. So I'm being very careful here. Make sure I do that. There we go. So this mystery wire is off. Now if you look inside the speaker, a little hard to see here. There we go. You can see the terminals inside. The terminals are connected to two wires that are heading towards the speaker cone. Now most speakers, you can see them coming out the front. Here they are there, these two here. The wires actually come through the cardboard and head down this way, underneath this dust cover. And then they've been painted into place to make them rigid and to seal up any holes that were produced in doing this action. The cone is moving. It's moving a lot. And it's moving not only a fair distance, it's moving many, 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 many times. So we all know about bending wires and breaking them, bending steel, coat hangers, and breaking them. They're only good for so many of these, and then breaks. Well, some of the wires involved here at some point are going to experience millions of cycles quickly. So I have to do something so that the cone can move, and yet these wires I just showed you are reaching these fixed terminals here. So in between the fixed terminals and the back of the cone, it's very hard to see with my camera shot, will be two fairly lengthy wires. Can you kind of see them there? Let's try another camera. Just see if we can get right in there. Is it going to focus? Are you going to focus? I don't think it's going to focus. Okay, so give me a second here. I'm going to force the focus on this camera so we can get a look at things. Just bear with me. I'll just do this live because it only takes about a moment. I don't know why it didn't automatically focus, but it didn't. I'll put it like that. Okay, so if we look inside, we can see the terminals coming through. Pretty tough looking, rugged things. Almost looks like a plug for an outlet. But off them you can see two more wires traveling all the way to the cone where we saw them popping through. By the way, that orange thing down below with all those convolutions, that's called the spider. And that's designed to hold the cone in a very fixed position laterally while allowing the cone to move, in this case the way I have it held, vertically. So it's usually hidden from view. In most speakers you can't really see it. Yeah, you gotta peek through a hole like this to see it. They all have it. So all in good shape. So those wires that are traveling from the terminals to the speaker are very flexible wires. Usually braided wires, no insulation. The insulation doesn't help. It makes them stiffer. And usually a braided wire, very fine wire, and they can take the vibration that's going to occur because the one end's moving and the other end's fixed. That's how they make these things last almost forever. Speakers are fantastic. But if you don't know these things, you can make bad mistakes pretty quick. Now, I can take this camera again and we can look right in here and see the so you see that what he's done here, he's connected these chunks of wire to the piece coming out of the transformer. Now the beautiful thing about copper is you can bend it a lot. Copper work hardens, which means as you bend it, the bend point where you've disturbed the metal gets harder than the other metal around it. So when you go to, say, you try to break a copper wire, it seems to be impossible. It's because it's hardening where you're bending it, and then the bend point is moving along the wire slightly. Now you're bending a different part of the wire. You can't get the spot bent enough times to break it. It takes a lot. So a piece of coat hanger wire, like 5 bends back and forth, and it comes apart right at the spot where you've been bending it because it gets weaker as you go. But copper gets harder as it goes. Now what about this white chunk here? These white chunks are useless. So really all I got to do is cut that white chunk off, and don't worry about it because the transformer is connected. Cut this white chunk off, cut off these wires, and then carefully take the transformer lead wire and put it back onto the terminal. Now, these copper wires in the transformer are insulated, and they've been insulated with a varnish. That's why it has that pleasant brownish color. That's not copper oxide. That's some kind of varnish put on it. We can't solder the varnish, and getting it off is tough, and working that wire is not a good idea. So I'm hoping when I cut these wires away, I'll be exposing solderable ends, a solderable end rather, to the lead wire. I'll just connect it back to the post. Hopefully you didn't shorten it. It's possible there ain't enough lead wire there to reach the post anymore. So I'm going to try to cut away, clean up, and get enough stuff here that I can solder it back. So some of the bits of wire may remain on here. Because if it's too short, I got to put an extension in there. And this is a tight little spot. It's not the, I'm not working in a big chasm here. So we'll get off the bulk of this wire here. Goodbye. I've got tape here. I can probably get this off. So I'm trying to not work the transformer wire while I'm doing this. For all I know, Grandpa worked it right to its limit, and I could take it over the limit. You ruin this, big trouble. Big, big trouble. You can't just grab another speaker. What are the chances it would fit in the cabinet? What are the chances this would be the right impedances and everything? Pretty small. Okay, luckily this tape is really in rough shape, so it's coming right off. There we have it. Now probably my best move is leave all this junk here for now, make the connection to this terminal. Okay, let's get rid of this. I'm going to leave the wire here too. It may be handy. Leave just a bit of wire. It may be handy. I can get rid of this too. I can get rid of some of this here. We don't need all this. Swing this up. All we got to do is just make a contact in here. Some kind of contact in here. That's a lot of wire. Okay, I'm going to stick the soldering iron on that. And a little bit of solder. Where's my little bit of solder? I'm just down to the very end of the solder. This was left of my roll of solder. It lasted me, I don't know how many years. Right down to the tail end of it. So I think the thing to realize if you're doing this kind of work on these old guys, on these old radios, is where the danger zones are, where you can get yourself into an accidental mess. You do something that leads to bigger, worse problems. Lots of bubbling in there. How am I going to know if this is even soldering up? There's a lot here to heat up. Oh, everything came soft. Yep. I can't hold it with that. That didn't work. I think. Well, it may be stuck. Yeah, you know what? That's probably good enough. When we go to use it, we'll find out. But I'm pretty sure that's good enough. So there we are. So the speaker is back to its happy original self. we're ready to plug everything together and play this radio. No, we're not ready. I have to put a new power cord on there. 2-prong, 3-prong, polarized. Lots of choices here. So the power comes into this here. Let's put on this terminal here, and on this terminal. This terminal is heading on the output line. No doubt it's heading up to the power switch on the front of the radio, quite a distance away. So it's traveling through this bundle. So the switch on the radio, they click it. Now the power's coming back onto one of these other terminals. You can guess it's this one, just a guess. From there it heads into the transformer, and you can just see there's just a huge supply of wires going in and out of the transformer. You hear this cracking? Well, 2 of these wires are the primary, the 120 volt wires. This is one. The other one is probably the one I pointed at. Can't be sure. Goes in, goes onto the primary winding, goes nowhere else in this radio. So when you plug it in the wall power kind of ends here in this transformer. It doesn't go anywhere else in the radio. And the point of that story, I'm not sure what was the point of that. So I'm going to leave some tails here. So it'll identify the terminals for me, because I'm going to go drink coffee, and when I come back I won't know what I'm doing again. Got to find a cord. Oh yeah, that's right, the 3-prong, 2-prong, or what. That's why I was talking about it. Different people do different things at this point. A lot of people install a fuse and do other stuff. I personally don't do those things. Put on a 3-prong plug and bring the green wire back and attach it to the chassis. I don't do those things. That's changing the nature of this. I guess some people would argue that it's a much better improved deal. The idea there is you have the green wire connected here, and one of the hot wires, you didn't solder it right, and it falls off and touches the case. It'll cause a short circuit, and it'll blow your house fuse or your house breaker. And you know you got problems. Otherwise, if the wire were to contact the chassis, there's a chance it just sit on it, and the chassis is now live. And someday you'll find out. You'll find out the hard way. Yeah, to me, it's better to install just a 2-prong cord and kind of maintain the way that they designed this originally. Polarized or not, you know, I guess you could say. There is some sense to which way you hook up the polarized plug back here, because some of the wires are traveling all the way up into the cabinet. So if you do it one way, you got quite quiet. You kind of have the ground side going up into the cabinet. Do it the other way, you have the live side going up into the cabinet. Probably better to have the grounded side go up in the cabinet. The thing to realize about that is once you turn the set off, the wire past the switch. I'm gonna shut up. I was gonna say would be live, but I'm gonna shut up. So I'm gonna find myself a nice cord, 2-pronger, probably polarized. Stick it in there, not be concerned about the polarization of it. And because this is pretty ruggedly done, and the wires are not gonna slip off and contact things. Nothing like that's gonna happen. Got that green stuff on my fingers again, which I think might be a little bit poisonous, so I'm going to clean up, drink some coffee, and come back with a cord. Okay, fetched a cord from my garage. Very cold out there. See my finger? That's called Raynaud's phenomenon. It's only happening on this one finger. Sometimes it's all my fingers. If I get cold, my body closes off the circulation in my extremities, my fingers. For some people it's their toes, it can even be your nose, earlobes, but for me it's fingers. I think it's probably the most common thing. occasionally I'll be outside doing something, got my gloves on. When I take them off, all my fingers look like this. They look like they've died. So yeah, Raynaud's phenomenon. A medically unimportant situation. It's not something to be too concerned about. Okay, so I'm going to fit in. I picked a rather ugly color of cord here, but it's nice and long. It is a polarized plug. It's in excellent shape, so that's why I've picked it out of my box of stuff. Just get rid of that. Easy enough. So this is the guy who's going to go in and be the power. So I think I'm going to take care of that in a moment. I go and drink some more coffee. Warm up my hand on a coffee cup. My finger. Okay. Let's just split this out. Oops. See if I can remove the original wire from here. Easier said than done. Okay, so lots of little bits and pieces of wire fell down in here. Not exactly what you want. Okay, got a wild strand off of this wire. Never got soldered in. That's the kind of thing that would cause the short against the chassis here. Want that to happen. we go. Not much stopping us from plugging this in now. Oh, I didn't solder this. Whoop. Oops. Yeah. There we go. Just one wild strand there. Good. They get tugged a little bit, but not too much. Good show. That's it for that. Now, where's my cloth here? Where'd my cloth go? Oh, here it is. Just use this to take most of this off. Tube only. Kind of that yellow stuff on here. A lot of military equipment has a lot of that yellow stuff, and like I say, I'm not sure, but I think it's a bit of a health hazard. It's not much in a radio like this that it's okay to eat. So this green stuff in particular, I think, is bad news. Okay, very close now to operating this. Okay, a couple interesting things here. By the way, there's a photograph showing how these wires are connected here for the antenna. They got to be done right. Can't be random there. So the antenna from this distance just looks like a coil of wire, but it's actually two coils of wire. One of them has a lot of turns, and then one will have only a couple of turns. You can see on the outside it's just a couple of turns. The capacitor I talked about earlier that tunes the antenna actually tunes the bigger coil out here. And none of that is actually connected into the rest of the radio. What's connected to the rest of the radio is the little coil here. The little couple of turns of wire picking up the signal from the bigger coil, which is resonating at the frequency that you're interested in, the one you've tuned to. So this is a transformer. This is a key part of the radio. If you get an old radio and it had an antenna like this, and the antenna is missing, because often it's on the back of radios, the back is gone, the antenna is gone, you're really missing something major in the radio. You're going to have a lot of trouble getting the radio to perform without an antenna like that. Another example here. I ripped this out of a junk radio. So not to study this too carefully, but again, it's not just two wires coming from it. There's something going on up here. Lots of I guess this is a part of the antenna has been peeled away on this junky antenna. But again, it's not just a single coil. It's more complicated than that. It's basically your classic resonant loop antenna. So that's connected. I also, when I took it out, I discovered there's a fan stock connector for you to hook up your long wire to it if you wanted to. get the wire out in your backyard and pick up that, faraway station. So we gotta plug this guy in here. This is the power cord. I don't want to twist things too much. This is not happy the way it is. I have to put a bit of a twist in it. Simply because I don't want to damage the wires. Okay, that's in. Speaker's plugged in already. Antenna connected, speaker connected, power supply connected. Put the knobs on the front here. Need to practice now. This is the on, off, and volume. This is the selector between phono and radio, but it actually has 4 positions. So it does 2 tone positions for each one. So it should be 4 spots on it. 1, 2, 3, 4. It's like this. Radio, radio, phono, phono. We're going to put it on the radio. Tuning's working fine, feels good. A couple of light bulbs popping through here. Interesting to see if those are any good. We are ready. I wouldn't jam this into a wall outlet and turn it on and see what happens, although I'll bet you it would just work fine. But I do have a way of safely energizing something like this. I've explained this many times, but I'm going to explain it again for new viewers. I use a dim bulb system. You can look that up on Google if you want to know more about it. System's a strong word for it. It's not much of a system. The idea is to anticipate a major short circuit in the thing you're about to power up. You run the power through a small light bulb. These 2 light bulbs kind of hanging here, a little loose these days. If there's a short circuit here, then the light bulb will come on full bright and stay that way. And I'm certainly going to notice. On the other hand, if there isn't a short circuit, the amount of power drawn by something like this will be enough to probably cause the light to come on a little bit. Won't be full on. Another effect too is when you first turn on anything like this, there's a I haven't even talked about this. There's a process of charging up the power supply capacitor. Here it is up there. Didn't really look to see what Grandpa did about this. I think he did nothing about it. Now this is a metal encased one. There's a really good chance this is in okay shape. Especially since Grandpa did his thing. No doubt this thing was working. And at that time, whenever that time was, 1980s, 1990s, whenever he did it, this was probably in good shape, or he would have done something about it and I would have noticed it underneath. So we'll hope. If this is not working well, we're going to hear a hum. If it's working really terrible, if it's shot, the hum is overwhelming. Scary. It can be scary, in fact. Not only it's dangerous, but it's very loud out of the speaker. You can't control it with the volume. It's a little scary. So I'm going to plug this into my bench outlet here. Now, just, if you're doing this kind of work in your home, it's up to you to maintain your safety. I can't help you with that. Primary principle of that is understanding what's going on in your shop with your equipment. And that can be a little more tricky than you might realize. So where I've plugged the radio in is actually hooked up to an isolation transformer, which means there is no direct wire connection between that outlet, this thing here, it's just an extension cord behind here, and the Niagara Falls generators. There's no direct connection. They're kind of similar in the radio itself with its own transformer, because what's coming out of here goes into the primary here, doesn't go anywhere else. Well, the radio is kind of double isolated away from the hydro system. That reduces the shock hazard to some degree. But again, you got to know what you're doing. Because for instance, when you hook up grounded test equipment, all my test equipment is grounded. As soon as you hook it up, all that isolation is over and done with. Okay, I'm going to take a peek under here just to make sure I didn't leave a big bundle of bad wire under there that would short something out. Nope, already. That's what's left of my 5-year supply of solder. But I have more solder. Just kind of a moment in time here. Okay, I think we're ready. So here's my expectation. To turn the power on with the switch off. Nothing should happen. Light should not come on. This thing will give me a reading of full line voltage. Actual voltage there is controlled by this other gizmo here, which I'm not making that much use of. It's dialed up for 117 volts or so, regular house voltage. Yeah, I have multiple layers behind this outlet. A little bit of overkill here. The other thing I've done is that what I like to do before I power something up is reduce my bench, get stuff off it. The reason for that is so that if something does happen, I don't have to look all over the place for everything. It's fairly nice and neat during the power up phase, just in case something weird happens, but I certainly don't expect that. So I have a little switch panel over here, just a little bit out of view. Switch here, switch here. This one arms my system. This one selects the power to travel through the light bulbs or to go straight. So at first I'm going to not push it down. It's going to send power through the light bulb. Keep your eye on the light. Switch is off. Nothing should happen. Okay, so you may have seen this meter jump up. I got it's overkill. 111, 112 volts here. That's good enough. That'll do the trick. So we're going to turn this switch. When I turn the switch down here, just make sure you can see my hand down here. We should see these lights come on. Shouldn't hear anything for a while. This tube, we should probably see it warm up. This one too, because it's glass, but the rest of them are metal tubes, metal clad tubes. I can't see anything. The main thing is this light. So both these bulbs are screwed in. They're in parallel, so the electricity will travel through both of these, not one after the other, but through both at the same time. You ready? Should I do a countdown? 3, 2. Okay, perfect. One light going. Everything's normal. Voltage here is dropped to 89. It's dropped because there's some voltage being lost across these bulbs. Voltage at first goes way down. Heater elements in the tubes are cold, so there's a bit of extra current. There's current charging this guy up. Just watching this, it's starting to go down. It's gone down, it's gone up. Now it's going back down again a little bit. That indicates the tubes are starting to conduct, which means they've warmed up. Got too much light on the rectifier tube to see if it's lit up. Yep, it's definitely lit up. That's a 5Y4 rectifier tube. So by now, if this capacitor were shot, I think we would hear the hum. I don't hear anything. So I'm going to advance the volume. What do we get? So that is probably being received by the antenna. It's probably not a problem with the radio. Now we're going to tune it. Here we go. Proof. Here comes the proof. Now that's a typical interference noise I hear all the time in my shop. I'm getting close to 590. That crackle is something probably in my house, some thermostatic control operating. Nothing to do with the radio, probably. When you hear the voice, it sounds like he's underwater. all those sounds are interference being picked up by the radio. That's the end of the road. Okay, capacitor in the back is completely closed. There's no more to go. Let's go back up. In my shop, it's lucky if a radio like this picks up one station at 590. There's a couple other stations. The better off the radio is, it can pick a few more up, but not much more than 4 or 5 stations in here. So we'll go back up here. Are they talking about sports? Yeah, I'm pretty sure they're talking about a player who was affected by COVID, some sports player. So that's 590. Next station that's possible to receive basically is 610. That's far away. That's in St. Catharines. Be about here. 640. .680. Of course, I'm guessing because there's no dial on here. Okay, then way up in the middle is a chance for 840, I think it is. Way up around here. This is a French station. So generally speaking, it's working actually quite well. That's a pretty good showing. No alignment's been done in any way. The antenna hasn't even been aimed. Let's fool with that antenna aiming. Put the French guy back in. Where'd he go? Where'd he go? There we are. Now we'll try rotating the antenna. It's just hanging from a wire here. So what's happened here is the antenna is directional in a funny way. It has, let's say, 2 directions at 90 degrees. One direction is strengthening whatever's in that direction, and the other 90-degree direction is weakening anything that's in that direction. So as you turn the antenna, you're doing this. The strengthening thing is not all that great. It's kind of a broad direction, and the amount of strengthening isn't that great. But the null is very sharp. So sometimes you can null out noise and hear a station. You're not actually getting the station stronger, you're getting rid of the noise. And I think that's what was happening here. Okay. You can see the noise and the station are kind of in the same direction, but it looks like let's go back down to 590 here. This is coming from the city of Toronto. It's about 100 kilometers away. So now the null is pointed at the station and it's gone away. So to go 90 degrees, that's probably the best. Just happens to be hanging the right way. That's something to realize about these radios. The antenna is fixed in the cabinet some way. You put the radio down, you try to tune in your favorite sports channel, you can't get it at all because the null is aimed right at it. You take the radio, if it's a table radio, turn it around 90 degrees or something in that range. Sometimes you have to fish for a while because you don't really know what direction things are in and all that kind of stuff. So you kind of have to hunt around for it and rearrange, hunt around. not to give up right away just because your radio doesn't work. Now, if your radio is a great big thing, great big floor radio, and the antenna is fixed in position, similar to this. This is a cabinet with the antenna fixed in position. There's a chance when you put it where you want it in your house, the null will be aimed at the station you're after, and you won't get it. And that's too bad, but that's what happens. Some radios overcome this by having the antenna mounted in a way that it can be aimed. So you reach around the back, you aim it maybe one time after you put your radio in its spot. Thumbs up. So, okay, what should we do now? I think we should stop and drink some coffee. I think that would be a good idea. Now, I don't have the alignment instructions for this radio. I haven't bothered. I'm sure they're available, but I haven't bothered with them. I don't think I need to. I think I can probably sort this out myself. What we'll do is feed in, what we'll do first, I'm going to see how much time is on this video, because maybe I'm at the end for today. And tomorrow we'll do the alignment stuff. So I'm going to check into that. And what about that underwater garbly sound? That's a bit of a problem. What I think would be wise to do is to do the alignment, see what we get, maybe test the tubes, see what we get. And if that doesn't find something that's related to the garbling, is a bit of a challenge here to get rid of the garble. Sponsored by Beer Canada, did they say? I don't think they said that. We're only running this at 90, by the way, so let's turn it up to full. Full. The garbling went away. Happy New Year. Yeah, I think the garbling went away. Good show. So I'm going to check and just see where we are in the video. If this is the end, then thanks a lot for watching. And tomorrow we'll do the alignment, finish this guy right off, back in the cabinet. He's ready to go home. I'll put a new light bulb in here too. Yeah, put 2 new light bulbs in. Great. There we go. Fantastic. Okay, thank you for watching up to this point. Or maybe there's more to come. Maybe not.